This video looks at the area and perimeter of a rectangle and a square. So first off, why do we use squares to measure area? Well, for example, circles don't fit together, so if you use circles to measure area, you would miss some of the actual area because there are spaces between the circles. The circles do not fit perfectly together. So that is a reason we do not use figures like circles. You could use a hexagon. This is a regular hexagon. All 6 sides are equal and all the interior angles are equal. And all the figures interlock with no spaces between them. So you could use hexagons, but the area of a hexagon is a lot harder to calculate than, say, a square, which is what we generally use for area, because squares fit together, and as we will see, the area of a square is a very simple formula. So we use square units to measure area. How many squares will fit into a certain space. You could even have irregular shapes, and you could have a standard size square, and again, the number of square units depends on the size of the squares you're using. Are you using square inches, square feet, square millimeters, etc.? Well, you literally see how many squares fit in, and then at the edges you're going to have fractional squares, and you literally could add up all the squares and determine the area of the figure. So the basic characteristics of a rectangle are: one, it's an enclosed figure with 4 right 90-degree angles, so it's like a enclosed fence area. There's no open spaces. This would be a figure that is not enclosed, for example. Opposite side, number 2, opposite sides are equal in length, so the opposite sides are equal in length. These double marks here mean these 2 sides are equal, and the single marks here mean these 2 sides are equal in length. So the area and perimeter rectangle, if I have 2 unit lengths this way and 6 unit lengths this way, and again it's a standard unit length that we're going to use, that's up to the size of the squares you want to use. So these are both the same length on both sides. So in this particular figure there are 6 units this way, or 6 squares this way, and 2 squares this way. So you can see there's a total of 12 squares. However, this leads to the idea of multiplication, because I have 6 rows and 2 columns. So the way to quickly calculate the area here is you take 6 times 2, and that's 12 square units. And I'm going to write U for units. So this is, we say 12 square units, or 12 units squared. In the next figure we have 4 rows and 3 columns. So you can see that there are a total of 12 squares again, so the area is 12 square units, and we can quickly calculate that using multiplication, where we have 4 by 3, and 4 by 3 is also 12 square units. And so U squared means, since the dimensions, let's say these are inches, let's just say they're inches for a second. If that was 4 inches and 3 inches, we'd be taking 4 inches by 3 inches, and that's 4 by 3, which is 12, and then inches times inches can be written as inches squared. So the general formula for the area and perimeter rectangle, the reason we have a formula is we then can specify the dimensions for any rectangle, and then we can calculate the area for any rectangle using this formula. So in general, we call the bottom here, sometimes it's called the length, I'm going to call it B for base. And the width, I'm going to call the height. Instead of having to write out base, I use the letter B. It represents the base. And so there are B units on the base. So for example, 1, 2, 3 could be any, depending on the size of squares, that'll determine the value of B. So I have 1, 2, 3, etc., 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 up to B units. Each unit is 1 unit on a side. And then the height the same way. I go 1, 2, 3, 4, up to h units. So my area is going to be b times h. There's going to be a total of, and each square here is 1 by 1, there's going to be a total of b times h squares. And that's going to be square units. The perimeter is the distance around the figure. Now you know that on a rectangle, the opposite sides are equal or congruent. So there has to be 2b. There has to be a b here and a length of b here. A length of b here, length of b here. That's 2b. Or b plus b. And then there's h here and h here. H plus h is 2h. So the perimeter of a rectangle is 2 times b plus 2 times h. So in this example, I'm going to try to explain what's going on when you actually have fractional parts on a side. So on the bottom here, my length is 3.3 units. Again, the 3.3 is determined by the size of my squares. I could have larger or smaller squares, and this value then would be different. But I have 1 unit here, 1 unit here, 1 unit here, and this would be 0.3 units. That makes a total of 3.3. And then this is 2.5 this way. That's 1 unit here, 1 unit here, and 0.5 units here, which is 5/10, and this is again 3/10. So the standard unit for this particular square is this square here because it's 1 by 1, so the area is 1 square unit. So this is 1 by 1, 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 this is 1 by 1. That's a total of 6. Now this is 1 by 0.3, so this is a fraction of a square. This is 1 by 0.3, which is also a fraction of a square. And then this is 0.5 times 0.3. 0.5 times 0.3 is 0.15. So let's move decimal point 2 places to the left. So this is 0.15, the area of that in terms of our unit square. This is 1 by 0.5, which is 0.5. This is 1 by 0.5, which is 0.5. And this is 1 by 0.5, which is 0.5. So I have 3 0.5s. So 3 times 0.5, moving decimal point 1 place is 1.5. Again, after a whole number, I need to put a decimal point. I need to line up my decimal points when I'm adding. And then I've got a 0.15 here, right here. Again, decimal points must line up when I add. Then I have 2.3s. Well, 2 times 0.3 is 0.6. So now I can add some placeholder zeros to help myself add. It's always a good idea when you're adding decimals to do this. This is 5, and this is 5, 1, and 6 is 2. Put my decimal point there, and then that is, I have to carry because that's 12, and then that's 8.25. Now that's a very cumbersome way to calculate the area here, but that is a way of looking at what's really going on. What we're going to do when we actually calculate the area of such a rectangle is we just take the base times height, because the area of a rectangle is base times height. My b is 3.3. My height is h, which is 2.5. So then I multiply those together. Put a placeholder 0 right here in the second row because I have to shift. So that's adding the columns here. That's moved decimal point 2 places. That's 8.25 square units, which is what we got doing it the other way. The perimeter is the same idea. You're adding up the sides. I got 3.3. I got 2 of those. So this was my area. My area was 8.25 square units. The perimeter, I have 2 3.3s, and I have 2 2.5s. Well, 2 times 3.3 is 6.6, and 2 times 2.5 is 5.0, or just 5. So I add those up. Again, after the 5, I need to put a decimal point. So I get my perimeter to be 11.6 units. And since perimeter is a length, it's not how much space is taken up, it's just a unit, it's not a square unit. Okay, so if I need to find the area of this rectangle, I just multiply base times height. So the area is B times H. I'm replacing B with the base here, which is 5.2. And I'm replacing the height here with 2. So I'm making this substitution. B gets replaced with 5.2 and H gets replaced with 2. This is also called evaluating the expression. Where B equals 5.2 meters and H equals 2 meters. This is a common word, the word evaluate. So then we just multiply those together. 5.2 times 2. Move decimal point one place. So that's going to be 10.4 square meters. Then the perimeter is just going to be 2 times 5.2, because I have two 5.2s as I walk around, because perimeter is the distance around the figure, plus 2 times 2. Well, 5.2 times 2 is 10.4. We already did that. And then 2 times 2 is 4. So this is going to be 10.4. Remember, after the whole number, you need to put a decimal point, so to line up the ones and the ones here. So add some placeholder zeros, bring down decimal point. So that's going to be 14.4 meters is my perimeter. Okay, then the square is a special rectangle where the base equals the height. So in other words, B equals H. Well, instead of using B and H there, I could use a single letter, and we usually use the letter S. So I can call all 4 sides have a length of S. So depending on the size of my squares, I have S units this way and S units this way. So the area of the square is going to be S times S, which we write as S to the second, or S squared. Again, that's pronounced S squared. That's an R. The perimeter, I have an S, an S, an S, and an S. So the perimeter is 4S. So the formula for the area of the square is S squared. The perimeter is 4S. Now you could actually, again, use the formula for the rectangle to get the square, because the square is in fact a rectangle, because it does have opposite sides are equal in length and 4 right angles. So our last example here, find the area and perimeter of this square. Well, the area is S squared. So in this case, that's 4.1 squared, which is 4.1 times 4.1. Add a placeholder 0, that's 4. 4 times 4 is 16. Move decimal point 2 places, so I get 16.81 square meters, because my units here are in meters. And then my perimeter, to finish off, I have 4 sides that are 4.1. So instead of going 4.1 plus 4.1 plus 4.1 plus 4.1, we just write 4 times 4.1. And 4.1 times 4 is 16.4 meters. And this concludes the video.